If you're looking for news related to Kubecon North America, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode, as you can see, is a bit special. We are at Salt Lake City in Kubecon North America. So during Kubecon, I was able to do a couple of interviews. So here you're looking at the part one from Kubecon North America with a couple of interviews. So I was sharing the experience with rejects, the observatory day, and of course, I will present a couple of observatory solutions that I have discovered during this Kubecon. If you enjoyed today's content, don't forget to like and subscribe to the channel. So follow me in Salt Lake City.
It's 6:40, and that's it. I'm starting my journey to Kubecon.
I'm a developer advocate at Altinity. We do managed services and support for ClickHouse. So here we are at Cloud Native Rejects, and yesterday I gave a talk that was a little bit about our observability journey at Altinity. So there's kind of two facets to that. One is how we view ClickHouse as a database purpose-built really for observability, and then also how we're doing observability for ClickHouse and for our cloud offering based on ClickHouse. So how is ClickHouse great for observability? Well, I think the key point is that observability data is write once, read many. And this is a use case where ClickHouse really excels, right? The merge tree architecture inside ClickHouse, which we can talk about more if you'd like, it allows us to have this very, very fast ingest where we can ingest at the rate of logging or tracing that requires. And then we can store all of that data efficiently in a columnar format that can be compressed very well, and we can query it with sub-second queries. And use cases where maybe you need to update or delete your data more often than you do in observability, maybe it's not so great, but for observability, it's awesome. Yeah, so how do we get the logs, metrics, and traces into ClickHouse? So there are a couple of different ways. There's a ClickHouse exporter for the OpenTelemetry collector. So if you want to use that, that has a schema that it will provide and create in ClickHouse for you, and it can send all of the supported signals directly to ClickHouse. There's also a Kafka table engine for ClickHouse. So you could basically take your data directly off of your Kafka topics and pipe that directly into your ClickHouse storage. And then in terms of getting the data out of ClickHouse, it's SQL compatible. So you're writing SQL queries. There's also a tool called Queryn, which is spelled Qryn, and that would then provide a translation layer so that you could query your ClickHouse data using PromQL instead of SQL. Queryn's really cool, and it supports a bunch of formats, and I'm not familiar with all of them, but I believe it supports Tempo, Prometheus, and OpenTelemetry, among some others. In my talk, I then moved to kind of what we're planning on doing with ClickHouse and how we're dogfooding it for our own observability. For us, since we're a database platform, right, traces, application traces are not that interesting to us because we only have a single binary that we're running. But the logs and the metrics are really important. We have a lot of infrastructure that we manage. The metrics for that help us keep that healthy. And the logs are really important for us to understand what's happening inside ClickHouse itself, how data is moved around. We're also using a little bit of eBPF with a tool called CoRoot. And so we're taking all of this information, right, and storing it right now in Prometheus and ClickHouse. But what our goal is to get to a place where we can take this data and basically dump it directly into S3 or other object storage, and then use ClickHouse simply to query that, for example, as Parquet. One of the challenges that we've run into, and I talk about this in my talk, right now there's no time series format for Parquet. So that's something that we're working with the community to see if we could create that and make that possible. I came from an observability vendor to a database vendor, but that's very intentional on both sides. We both see this observability use case for ClickHouse being very, very important. And we see it being part of the future of ClickHouse. And for me, I also see data sovereignty in observability being really, really important. And so if we have a tool that can help people own their own observability data, keep it on premise, keep it in their own clusters, both for legal and compliance reasons and for technical reasons, right? Moving this data around is expensive. So I think that this is going to become more and more important in observability. and I'm really excited to help show people how they can do it. How do we get telemetry out of ClickHouse, and do we plan to improve that? I talked about this a little bit in my talk. ClickHouse is actually pretty awesome because it's kind of self-instrumented. And so you have these system tables that provide you with built-in metrics, traces, and logs. And I said we didn't care about traces, but we actually do use the internal traces that ClickHouse provides. And those are actually already OTel compatible. So you can already just query ClickHouse directly and get OTel compatible spans about the ClickHouse internal operation.
First day, observability day. So I think very excited. Usually it's the best day of KubeCon for me. I mean, from an observability perspective, very excited. The schedule seems very interesting. There is a couple of talks that I really want to listen
My name is Braydon Kains. I'm a software developer at Google. I'm working in the Google Cloud org on the cloud observability product, and my main job is to work in the open source projects that benefit our product the most. So FluentBit, OpenTelemetry, and some other tools related to those. The talk I'm giving this time around at Open Observability Day is a deep dive into how FluentBit collects file logs. The reason I pitched this talk originally, and sort of the message that I hope people take away, is that, you know, we can really easily sort of identify how writing to a log works. You know, observability is a complicated field, but all of us can understand printf to a log or something like that, something along those lines. But then collecting those logs out of a log file to put them somewhere useful is an extremely complicated topic in comparison. And so my talk is going to, in as much depth as I can get in the lightning talk length, 10 minutes, I'm going to talk about how FluentBit has implemented collecting these file logs, because there's lots of ways to do it. And FluentBit chose one strategy, and my hope is that either as a user you can take away an understanding of what FluentBit is doing under the hood when you're collecting this data, or if you're someone who's interested in other implementations, you can sort of learn what you're looking at to compare between different agents and see if you might prefer the way another agent does it. When it comes to actual ingestion from a log, one of the hardest things to get right to make sure you're not, you know, overloading your system. One of the hardest things is that when you're an application writing to a log, you're not really thinking about the rate at which you're writing or the rate at which stuff is going to get read. You're just hoping that you write to a log, something's going to collect it and something's going to send it out. But if you've configured your FluentBit instance to do a lot of processing, you can sort of, let's say, fall behind. FluentBit can only do so much at once. The hammer's got to drop somewhere. If you're writing so many logs to your system and rotating your logs so fast that you overload the rest of your pipeline, you'll lose logs eventually. There's really no way around it. So FluentBit has a lot of ways to control this. For one thing, FluentBit will process logs after a rotation, as long as it detected a rotation. So if you're rotating really fast, but you want to make sure that you're still capturing the logs you might be missing, you can configure FluentBit to wait for rotations, wait to purge rotated files for a certain amount of time. I believe the configuration is called rotate wait. So you could set it to wait for a minute before purging old logs to make sure you're capturing old stuff. And then there's also buffer chunk size and buffer max size. These are configurations on the file input for how much data FluentBit will be reading at a time. Because on every file, it keeps a local buffer of what data is being read at once. And it'll try and reallocate that buffer to be larger if there's more data in a certain read event. And up to a max size, like 10 megabytes is pretty common. Like, you don't want to read more than 10 megabytes of data at a time. Otherwise you'll overload, but you don't want to make that so small that every read you're only getting a little bit of data drip feeding, and then you're going to start losing logs and falling behind. So finding the balance of the size of the buffer, making it not so large that you're overloading your pipeline, but not so small that you can't keep up. That's the main sort of knob that you're going to be turning to make sure you're getting the most out of your FluentBit instance. So FluentBit's very good at parsing logs. Maybe you have JSON or some other structured log format, or you have multi-line logs like exceptions or things like that. And FluentBit is capable of processing those in 3 ways. Either you can configure your parsers and multi-line parsers directly on a tail plugin. So basically, as FluentBit is reading data, before it even gets written to the rest of the pipeline, it's going to do the parsing in place. The other option is to do it as a filter plugin. So that means somewhere down the pipeline, usually first, if you want it to work the right way, early on in the pipeline, as a filter plugin, you can do the processing of log data at that point. And then the third option is if you're on a newer version of FluentBit, newer than I think 2.1 or something in that range, then you can run your input plugins in their own thread, and at the same time your filter plugins can run in that same thread as a processor. So before they get written into the main pipeline in the main thread, you can process the logs in the input thread. Out of those 3, I think they all come with upsides and downsides. When you're configuring your multi-line or parser plugins directly on the tail plugin before they get written into the pipeline, I think the main thing is the actual processing of data, log ingestion, can slow down because the tail plugin has to do so much extra work before data gets written into the rest of the pipeline. You can hinder yourself a little bit. The upside is that it's a bit more performant than the second way, which is to configure the multi-line or multi-line or parser is as a filter plugin. FluentBit all runs on one thread, unless you use a threaded input or threaded output. Everything that FluentBit does, all filters, all inputs, all outputs that are configured as such, they all run on one thread. The more filters you add in, the more output plugins you have, the more input plugins you have, the more of these things that aren't set off into threads, the more bogged down everything gets. Everything is affected by adding more filters and more input plugins, more output plugins all in one thread. The upside is that you can reuse. It's easier to configure filter plugins. If you have a multi-line parser that you want to apply to all kinds of input plugins, it's easier to configure that. So if you're really not too worried about general throughput, if you're on a light load, no matter how bad air quotes you configure your FluentBit, it's going to be tiny anyway. So this is really only once you're getting into like many megabytes a second is when you start needing to think about alternate strategies. As a default, configuring as a filter plugin works. And then the last way, which is the tail plugin running as a threaded input and the filters running as what FluentBit calls them processors. They are a little bit different under the hood, but the concept is the same, that it's a filter plugin that is designed to run in thread alongside of the input plugin. And I haven't done much science on it, but it is theoretically one of the best ways. I think because the input is not hindered, and the data might be slightly delayed. It's not a perceptible delay, but it's a bit more work before it gets written into the main thread. But I think theoretically it's probably the best of the 3. So if you're someone who produces a lot of logs at once and you really are performance sensitive about those logs and you want to make sure that you're not overloading, your pods or your infrastructure with just doing a bunch of log processing, there is sort of 2 main ways that I like to think of running things like FluentBit or the OpenTelemetry collector, and that's either as an agent or as a gateway or collector. Different ways people like to do it. But either FluentBit is running alongside the stuff it's collecting or the stuff it's monitoring, or it's running separately and data is being sent to it. I think there's reasons for both to exist. I think with collecting files from logs, I think that's inherently, FluentBit can only collect files from logs if it's running as an agent. I mean, there's tricks with it, like you could run it as a daemon set on your node and collect stuff for lots of pods, but functionally it's running alongside the infrastructure that it's monitoring. It might make sense if you're someone who needs to do a lot of processing or a lot of very weird specific routing on that data, to keep a lot of that processing out of the agent and into somewhere like a collector, or if you have a backend that is able to do some of that routing. Like some of the cloud providers have special routing capabilities or will allow you to write dump special logs that you don't care that much about straight to a bucket or something like that. I think if you're very performance sensitive and you want to make sure that your infrastructure is not hindered by lots of processing, the more intense processing that you can offload into a gateway is going to be you're going to be better off, especially when it comes to like the collector has something called a target allocator, which means that it will automatically sort of multiplex or load balance different things that it's processing onto like a fleet of collectors. I'm not explaining it the best, but strategies like that where you can load balance high amounts of data, or you can scale your gateway collector with the increased log volume that you're getting, it can make sense to have more of that processing happen on the back end than within the agent.
First day at Kubecon, very excited to see the keynote, to discover the venue, because at the end everything was closed yesterday.
So my name is Laurent Broudoux, and actually I'm the founder of a CNCF project that is named Microcks. And Microcks is a project that is dedicated to API and services mocking and testing. We are here today for Kubecon North America in Salt Lake City, and it will be my third time attending at Kubecon. Two last one have been as a project. Because we entered 1 year ago, the CNCF being now a sandbox project, and this is the very first time we will be speaking about Microcks at the Kubecon. We have a track in the collocated event that is named the App Developer Con. So we will talk tomorrow about streamlining your cloud native development experience with Microcks. Yes, exactly. So what we are trying to do with Microcks is to enhance the developer experience or the developer learning curve when starting cloud native experience, because we figured out that most of the time developer is struggling with a lot of different dependencies to manage, because distributed and cloud native systems are made of many service dependencies, and it's really hard to set up a development environment, and also to have a reproductive environment, and also to ensure that the development we are actually coding do not break anything, do not introduce breaking changes in the pipeline. So Microcks is here to solve those two problems. The first problem it solves is that it provides realistic simulations for your service dependencies. So instead of trying to have all your dependencies in line, you can just rely on realistic simulations that are provided by Microcks. It's the mocking side of things. And the second problem we are addressing is about giving the developer the confidence that he does not introduce breaking changes. So Microcks allows also the developer to do a contract testing on the new service, on the new API he is actually developing. I would say the first layer of contract testing is we're trying to check the technical conformance of a new service, of a new API. So basically it means that my API that I just developed is valid regarding a JSON schema, regarding a protobuffer schema, regarding GraphQL schema, and so on. So it means that what is put on the wire, you will be able to to understand it and to use it to make it usable by your consumer. So this is the first layer, the technical layer. And the other layer of contract testing we integrate is much more about the semantic or the business rule conformance. That means that, for example, if you provide a new service to allow searching within a catalog, you want to be sure that the results you actually send out are conformant to the different filter criteria that were issued by the requester. So this is more about checking the business constraints and the expected behavior the service must match. The motto, the mantra with Microcks is trying to not reinvent the wheel. So we are reusing a lot of different artifacts that may already be there in your organization. So typically, Microcks reuse those artifacts. So it could be OpenAPI files, Swagger files, it could be a protobuffer definition, it could be a GraphQL schema, and so on. And Microcks reuse all these assets to build up new simulations live. So typically those assets already exist. They are in your Git repository, and Microcks is able to connect to your Git repository and to discover the different services, different data sets that maybe already exist, and just create new simulation from those data sets. So if you're in this way of doing things, providing contracts to your consumers, describing data sets and so on, it's really easy to get things working. So basically you can mock everything that relies on HTTP or HTTP2, so REST API, gRPC, GraphQL, and so on. And you can also mock asynchronous protocols and event-driven APIs. So basically, if you are using events in your system, using, for example, a Kafka broker or a NAT broker or RabbitMQ, MQTT, whatever, we have also this ability to create mocks from this asynchronous API definition. So you can see by this little diagram, this little atom, all the different technology we are support or we are integrating with. And so basically Microcks is a cloud native tool. So it means that it is made of different containers. It is made for being deployed on Kubernetes, but you can also very easily use it on your laptop. I would say that the most easiest thing to do to start with is just run a Docker run command, okay, and just Docker run, and yes, launch Microcks image. You can see this is the latest, and we have a native compilation here, so pretty quick to start. So now we have started Microcks. Here it is on my localhost 85, okay. And so Microcks, yes, just provide a UI. You can use it also through the API if you just want to, don't take care about the UI. And so it acts as a natural repository for your different APIs and services. And so the first thing to do is to import new stuff into Microcks, import OpenAPI files, import Postman collection, import YAML files that describe your datasets, for example, and we will just create the mock for you. But the other way of doing things is also to connect to some kind of marketplace. We call this a hub, where the team can distribute new mocks very easily. So here we have, for example, the hub, and you can see you have access to different style of, yes, off-the-shelf API, but you can also have access to the Microcks samples we provide, okay, and have access to different technologies. So, for example, if you want a gRPC or mock, or the one you should all have in your API catalog, the API about pastries, okay, so you can just install this mock. And what Microcks is doing here is just importing an OpenAPI file, okay? And from this OpenAPI file, you can see that it has discovered an API, okay? I can get it from the catalog, API pastry here, version 2.0. And it has discovered the different operation of this service, this API, and it has just created endpoints so that you can start working with this API on the fly, as it was a real service that already exists, okay? Here is the experience on the developer's laptop, but obviously, so you can use it, you can use Microcks on your laptop, but the other way of using it is also to deploy some kind of central instance that is always up and running for your different development team, sorry. And for doing this, we provide a Helm chart, or we provide an operator. So I would say if your support operator is just installing the operator on your cluster, and then we have different CRDs, so you can just create a custom resource for having a new Microcks instance. So the operator takes care of popping out a new instance. And then you have different custom resources for feeding Microcks with new specs, for feeding Microcks with new authentication secrets if you want to connect to an existing broker, for example, or if you want to connect to your in-house GitHub instance, for example. So everything can be used in a GitOps way, way of doing things. So we have a bunch of different custom resources we can instantiate to help manage Microcks on the fly through the API, from the API. So we provide observability feature via OpenTelemetry support, because one of the use cases of Microcks is to use it to mock your dependencies when, for example, you want to check the performance of a system. Instead of having this system plus all the dependencies in line, it's much more easy to just deploy this system and mocking all the dependencies with Microcks. And within this use case, it's very important to know the real performance of the different mock, also to get some detailed information on where did we spend time. Is it talking with the database? Is it talking with the broker? Is it just managing the HTTP layer? So we provide support for OpenTelemetry, and we also provide some kind of standards off-the-shelf dashboards from Grafana. So if you want to deploy Microcks and check that it is actually not the bottleneck of your performance testing campaign, it's very, very easy to integrate it into your OpenTelemetry observability stack. So we tagged everything so that you can be sure that the provenance is a tag and not a real production system, and then get additional details on the spans and so on, so you know where you spend time. Yeah, so if you want to start with playing around, testing Microcks, so obviously the easiest way to do so is by visiting the website. So it's microcks.io, and you will see that we provide we try to provide the most comprehensive getting started experience with a lot of quick starts of tutorials on how to configure your first mocks for GraphQL, for gRPC, and so on. We also have a Discord channel, so a Discord server. So if you want to join us, we are available on Discord. And we also have some channels on the official CNCF Slack. So.
My name is Mirko Novakovic. I am the co-founder and CEO of Dash0. And before that, I co-founded and was CEO of Instana. So both observability companies. With Instana, it was the first APM for Kubernetes. And now we are building an observability solution that's OpenTelemetry native. So how long has Dash0 been in the market so far? We are in the market 1 week. So essentially we released the product last week, a week before Kubecon, but we are developing it for 1.5 years. When we founded Dash0 was to build a solution that's 100% built on top of OpenTelemetry. And I think the difference just is being OpenTelemetry native is that we do not integrate OpenTelemetry to then convert it in our own model. We keep it in the OpenTelemetry model. And when you look at the tool, you will see the signals of OpenTelemetry, logs, spans, metrics, but you will also see the component model, the resource model of OpenTelemetry in full support for the semantic convention. I think that as a community and as OpenTelemetry can still do a lot to make it easier for customers to adopt OpenTelemetry. Today it's not that easy, right? You have to understand the collector, you have to understand how to put the agent in place, how to elect metadata in the right way. So what we did, and it's actually open source, we built a Kubernetes operator which helps you assemble all the components, the standard components, so we're not changing them, but we help assemble them, right? So the operator basically puts in place that you get all the Kubernetes metadata, that if there is, for example, Node.js running, that the agent is injected and that you don't have to do it yourself, right? A little bit like what most of the other commercial observability solutions have, an automatic agent. We try to simulate that with the operator, but it only works in Kubernetes. You can decide to use the community operator. It will work out of the box with Dash0, or you can use our operator, which is basically a fork of the operator, and it's adding some functionality to automate the process of, for example, injecting the agent. So Dash0 is not fully open source. So especially parts of the backend are closed source, but we are open sourcing more and more of the platform. We have started with a component that's called OTelBin. It's also OTelBin.io. And that's a visual configurator for the collector. And we open sourced it. And the other is just what I mentioned is the open source operator that we are just releasing. And we are thinking of open sourcing more and more of the components over time. So the thing is, if you open source things, they are open source and they should be open source. And we appreciate very open licenses like Apache 2 that you can do whatever you want with the license. And then there is no way back. And if you go way back, we have seen that in the community, that's not really appreciated, right? So our idea was, okay, if we open source something, there's no way back, right? And everything we open source will stay open source forever, and also with the license we put in place. Dash0 is pure SaaS version. So the only way to use us is basically you can have the collector inside of your data center and do whatever you want, also remove data, but then you send the data to Dash0 and that's fully managed in the cloud. As OpenTelemetry native, we want to support everything that OpenTelemetry has, but we are a startup, so we had to decide where to start. And we started with the signals that are most stable, so metrics, logs, and spans, that's fully supported. But yes, we will support RAM next. We will support profiling, and we also will support OPM and the pipeline thing that comes with it. That's definitely on the roadmap, but it's not yet supported. So the question is, how do we query the data, right? And first of all, we would appreciate if that would be standardized, and I think there were some approaches to do that, but they haven't been finalized. And I also think that this is a topic where you can be very opinionated between something that's SQL-like, something that's more Custo-like with the pipes, or something that's more like PromQL. We have decided to go 100% PromQL for all signals. So you can use in Dash0 PromQL for metrics, logs, and spans. And the reason for that was not, first of all, we think it's a very well supported and known language. But also, to be fair, it's not easy to learn, right? So we have seen a lot of users struggling with it. So that means you have to give support to make it easier to use PromQL. But the big benefit is that you can use things that the community has built. Just as an example, there's a project called Awesome Prometheus Alerts with more than 500 alerts that are based on PromQL. So you can have an alert for MySQL or for Kubernetes. And because we use the same language, we can now import that knowledge and you can reuse that knowledge inside of Dash0. Or with Perses, which is also based on PromQL, you can now create something like awesome Perses dashboards, and you can build the dashboards and the queries in PromQL. So we think PromQL is kind of a de facto standard in the community around the CNCF projects. And so we wanted to reuse as much as possible from the community. And that's why we decided for PromQL. You can see here the starting screen. It's basically a service map. What you see on the left side is basically what the core things of OpenTelemetry are, right? Resources, tracing, spans, logging, metrics, and then we added things like alerting and dashboards. Dashboards is based on Perses, also now a CNCF project. And what you see here is the OpenTelemetry demo application. And these are services. And the thing here is that we really use the semantic convention to give you the context in a nice way. So everything here is basically key value pairs derived from the OpenTelemetry semantic convention, right? This is the language, this is the version of the language, these are Kubernetes namespace and deployment, this is an AWS account at AWS zone. You see all that, right? You see if there were failed checks, which is basically problems with this service. You can see the core red metrics, request, errors, and duration. And you can see the operations, basically the API. You see all the HTTP requests here to that front-end service. And what you can then see is we use the semantic convention to also combine all the signals. So you can see of that service, all the spans, all the logs, all the metrics of that service, right? And what I can do, I can drill into it. I can say, oh, show me this. And now I get all the spans. Here's a nice heat map showing you the spans. And here I can see all the spans right in context. I can see the trace. I can see the attributes. And what is nice is we support that you can filter for every attribute, right? For every attribute in the semantic convention. We also show you the documentation, so what that means. But if I click plus, I now filter for all the stuff that has 200 OK. But if I would say minus, now I can see everything that does not have a status 200 OK, You can see here 500, for example, right? So it's easy to filter, but you can also add this to the table. If I click this button, now I have added the status code to this table here, and I have the status code directly in the table, right? So it's really fast to use a semantic convention with the product, right? I can also jump to the trace, see the full trace. This is a very short one, but I can see the trace. I can see the logs and events of that trace, can directly jump to them. And by the way, which I like a lot, you can see here Shift F, for example, everything is keyboard based. I can search everything. I can filter everything, right? So I can say filter for this method. That's very convenient, right? Very fast to use, very easy to use. Everything is keyboard based, and it provides all the core functionality of OTel, right? And also here you can see even in the view, I can always filter. I can always add it as a column, right? The same is true for logging. Here are the logs, right? I can filter and search in the logs, right? For something, I don't know if HTTP is in there, something, no, it's not matching. So I can search, I can slice and dice, and I can see the context. If I click on a log, on the right side, I can see the span context, again, see the full trace, and see exactly where that log was created, right? And last but not least, we have all the metrics. So we have Metric Explorer, where you can search for metrics, where you can look at each individual metrics. And with the query builder, that's what I said with PromQL, we make it easy. You can, for example, say based on a service, I want to query the error count of my whatever ad service, shipping service. And here you see the PromQL, right? So we will generate the PromQL. And now I can say add to dashboard or create a check rule. So to directly create an alert or a dashboard based on that query. Coming to checks, I just want to show you the awesome Prometheus alerts, right? So if I create a check, I can use the query builder. I can directly go and do PromQL if I know it, right? That's kind of the expert mode. But here's the templates, right? That's what I meant with awesome Prometheus alerts. So I can see here Kubernetes. I can look, Kubernetes job failed. That's a predefined error. There's a predefined expression in PromQL. And we also show you if the metrics that are used in that are available. So I know, okay, this is actually something I can use, right? But I have that for everything, right? I can do that for Kafka, for MySQL. And these are community-based alerts that I can reuse because we are open to it, right? Here you can see we have the resource browser, and we call it Resource Explorer. And here you can see Kubernetes. And with Kubernetes, we use the structure of, based on the semantic convention, you can definitely browse through the namespaces, and then you can open it, you can see the pods. For each pods, I can click on it, get the data, right away. So there's a way, by the way, you can do it everywhere by pressing Shift E. That's the Explorer. And I can also search in it. For example, I could say add service, and then it shows me everything like the services, the replica set that has app service. I can see the namespaces, the pods, and not only can I jump here, I also see the number of metrics. I can see the number of logs and the traces. And if I click on it, now I jump directly into the traces of that service that I just selected, or the namespace or whatever. So everything is really with the Explorer. So Shift E everywhere, and you can jump directly to your Kubernetes resource that you want. And last but not least, it's dashboards. So dashboards are essentially based on Perseus. So if I click on edit here, you can also see that I can basically see the source. I can also import Perseus dashboards, and then I can literally configure any dashboard with metrics, with logs, with traces. Can use PromQL, or I use the query builder to build the dashboards myself without knowing PromQL. Yeah, so the question is where I get details about the product and how I can try it. It's a free trial, so you can just go to the website, log in, send your data to it, and test everything. It's unlimited, so you can test it for 14 days. And yeah, that's it. And then we don't have a free forever version, but we have something that you can use pretty heavily for $50 a month. And that's basically how the service works.
today's episode, the part 1 of Kubecon North America. Very excited to hear about this open source project that you are mocking. I think it's really useful in community environments, especially if you are dealing with microservices. So having this solution will just simplify our processes to test. So very excited about this. Also, I really like -0, the way they present things, really interesting. So I will definitely follow the projects and the solution in the future, because it seems to present the data in a different way. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. See you soon for another episode. Bye.